Welcome to the lecture series on numerical methods, finite difference approach. In the last lecture, we have discussed a hyperbolic equation and its solution procedures. So, based on explicit method and implicit method. In the present lecture, we will just go for this stability and convergence analysis of this hyperbolic equations. So, if you will just go for this stability analysis of based on this explicit scheme here. So, especially this explicit scheme for this hyperbolic equation, that is just defined in the form of if the hyperbolic equation is as del square u by del t square, this equals to del square u by del x square with two initial conditions and two boundary conditions prescribed. Then this discretization equation at the j plus 1th level, it is just written in the form of ui j plus 1, this equals to r square ui minus 1 j plus ui plus 1 j plus 2 into 1 minus r square ui j minus ui j minus 1. Easily you can just find this equation, since if you will just discretize this equation, that can be written in the form of ui j minus 1 minus 2 ui j plus ui j plus 1 by del t square plus order of del t square, this equals to u I plus 1 j minus 2 u I j plus u I minus 1 j by del x square plus order of del x square. If you will just consider r equals to del t by del x and neglecting the higher powers of x here, then we can just write that one as u I j plus 1, this equals to, since it is just defined as del t by del x whole square here. So, that is why r square it is just coming into the picture. So, ui minus 1 j plus ui plus 1 j, this into r square, since del t square it can be just come it off, and del t by del x whole square if you will just write. So, we can just write these terms there itself as in this form here. That is why it is just written as like a r square into ui minus 1 j. So, this is written as r square ui minus 1 j plus ui plus 1 j plus 2 into 1 minus r square ui j minus ui j minus 1. I is varying from 1 to n minus 1. So, this equation is a linear equation in a u. Therefore, the formula for the error can be written as in the same manner as we have defined in the earlier lectures for parabolic equation and elliptic equations. So, the error term, it can be just written in the form of e p q plus 1, since if u is the numerical solution here and u star is the approximated solution. So, if you will just take this approximated solution minus the true solution, then especially it is just written as e of p q plus 1 based on this I j plus 1 points. We are just replacing this one as I as in the form of p here and j plus 1 as q plus 1, where e of p q it can be written as in the form of u minus u star at p q point. So, that is why it is just written in this form here. So, e of p q plus 1, this can be written as r square. So, based on this like u minus u star at I minus 1 j point, it can be written as e of p minus 1 q point plus u minus u star at I plus 1 j point, it can be written as e of p plus 1 q plus 2 into 1 minus r square, and u minus u star at I j coordinate, that can be written as e of p q there minus u minus u star at I j minus 1 point, that can be written as e of p q minus 1 here. And especially we have just replaced that one e of p q as in the form of e to the power alpha q del t e to the power I beta p delta x. Already we have explained these things in the previous lecture, that is for like parabolic equations and elliptic equations. So, that is why here directly we are just writing this error term in terms of exponential powers. And if you just put this power terms as in the form of error term here as the coordinate p plus p q plus 1 here. So, this can be written as e of p q plus 1 as e of alpha into q can be replaced by q plus 1 into del t e to the power I beta. So, p is they are present. So, p delta x this equals to r square, p minus 1 especially it can be written as a p minus 1 here. So, e to the power alpha q del t e to the power I beta into p minus 1 delta x plus e to the power alpha q, since it is just written alpha q del t e to the power I beta into p plus 1 del x plus 2 into 1 minus r square and e to the power alpha q del t e to the power I beta p delta x minus e to the power alpha into q can be replaced by q minus 1 here. So, q minus 1 del t e to the power I beta p delta x. So, if you just cancel some of these coefficient terms there itself. So, we can just get this equation as e to the power alpha del t this equals to r square e to the power minus I beta delta x plus e to the power I beta delta x plus 2 into 1 minus r square minus e to the power minus alpha del t. And if you will just put here e to the power alpha del t equals to zeta here, then zeta can be written as r square into, if you will just see here, e to the power minus I x plus e to the power I x by 2, it can be written as like a cos x here. So, that is why it is just written as a, if you will just see here 2 cos beta delta x, since it is like my e to the power minus I beta delta x plus e to the power I beta delta x by 2. So, that is why 2 into cos beta delta x here plus 2 into 1 minus r square minus e to the power minus alpha del t. So, that is why zeta to the power minus 1 it is just written. If we will just multiply zeta both the sides, so then we can just obtain zeta square this equals to 2 into r square. So, if you will just see here, so zeta is multiplied means you can just consider this 2 into, so r square cos beta delta x minus 1 plus 1 into zeta minus 1. And if you will just linearize once more, then zeta square this equals to 2 into r square. So, usually you have known that cos 2x it can be written as 1 minus 2 sin square x. So, that is why it can be written as like cos beta x, sorry, cos 2x minus 1, this is like minus 2 sin square x. So, that is why if we will just replace here cos beta delta x, so it can be written as like minus 2 sin square beta delta x by 2 plus 1 into zeta minus 1 there. So, this can be written as like zeta square minus 2 into 1 minus 2 r square sin square beta delta x by 2 whole into zeta plus 1, this equals to 0. So, if we can just see here, this equation is a quadratic equation. So, this contains 2 roots. Suppose these roots are in the form of zeta 1 and zeta 2, and if zeta 1 and zeta 2 are the roots of this equation, then we can just write zeta 1 plus zeta 2, that is nothing but you can just write minus b by a. So, if equation in the form of ax square plus bx plus c equals to 0, usually if alpha and beta are roots of this quadratic equation, then we are just writing this alpha plus beta equals to minus b by a and alpha into beta this equals to c by a. So, that is why we can just write sum of these roots as 2 into 1 minus 2 r square sin square beta delta x by 2, and zeta 1 into zeta 2, if you will just see here, this coefficient has 1 here, this has coefficient 1. So, c by a means this is nothing but 1 there itself. So, from this equation if you will just see here, since zeta 1 and zeta 2 equals to 1, we can just write absolute value of zeta 1, this can be written as 1 by absolute value of zeta 2, implying that it must be absolute value of zeta 1 should be less than 1, then absolute value of zeta 2 is greater than 1. If you will just take in that form, this means that 1 by 5 into 5 it should be 1 there. So, that is why if 1 is less than 1, then other should be greater than 1, then we can just obtain this relationship and vice versa. So, but for the stability we must have to get absolute value of zeta 1 should be less or equal to 1 and absolute value of zeta 2 should be less or equal to 1. Therefore, stability we have to consider here absolute value of zeta 1 equals to absolute value of zeta 2, this equals to 1. But if you just put this relationship in the first relationship here, then we can just get this relationship as absolute value of zeta 1 plus zeta 2, this equals to 2 into 1 minus 2 r square sin square beta delta x by 2. And if you will just see absolute value of zeta 1 plus zeta 2, always it is greater or equal to zeta 1 plus zeta 2 there itself. So, it must be greater or equal to 2 into 1 minus 2 r square sin square beta delta x by 2 there. And obviously, we can just write this one as 2 into 1 minus 2 r square sin square beta delta x by 2, since zeta 1 is considered as 1 there and zeta 2 is considered as 1 there. So, that is why you can just write as 1 plus 1. So, I just want to repeat this one, since we are just considering absolute value of zeta 1 plus zeta 2, it is less or equal to zeta 1 plus zeta 2. So, that is why this relationship establishes here. So, if you will just take this in a inequality form here, then we can just write this one, since 2 can be divided here, and we will have this inequality as minus 1 less or equal to 1 minus 2 r square sin square beta delta x by 2, it should be less or equal to 1 there. So, from the left inequality we can just write this one as r square. If you will just see this one r square, it should be less or equal to 1 by sin square beta delta x by 2, and this means that r square should be less or equal to 1, since the maximum value of sin x should be lies between 0 and 1 there. So, that is why we can just consider in absolute form. So, in this case we can just consider r square should be less or equal to 1 always for the convergence of explicit scheme. And especially if you will just see here that sine curve, if you will just see. So, this is nothing but the cos curve here. So, sine curve, if you will just see, this is just lying between like 0 to 1. So, that is why sine of x is always less or equal to 1. So, that is why this relationship should be justified. Hence, we can just say that r is nothing but del t by del x, which is stable if r square is less or equal to 1. This means that del t by del x whole square, it should be always less or equal to 1 for the stability scheme to get the solution in explicit approach. Or we can just say that whenever r square is less or equal to 1, we can just obtain the solution for hyperbolic equation using explicit scheme. So, if you will just go for the stability analysis of implicit scheme here, the implicit scheme especially, this is just written in the form of minus r square ui minus 1 j plus 1 plus 2 into 1 plus r square ui j plus 1 minus r square ui plus 1 j plus 1, this equals to r square ui minus 1 j minus 1 minus 2 into 1 plus r square ui j minus 1 plus r square ui plus 1 j minus 1 plus 4 ui j. Especially what we are doing is, in the implicit scheme we are just considering this central difference approximation for time derivative, that is nothing but ui j minus 1 minus 2 ui j plus ui j plus 1 by del t square, and for space derivative we are just considering this average of this derivatives at I j minus 1th level and I j plus 1 level. So, we are just considering this average of these two schemes there itself. So, that is why we are just obtaining these schemes are in the form of if you will just see here j plus 1th level, one of these values we are just obtaining, and j minus 1th, some of these values we are just obtaining. So, that is why if you will just solve these two equations at like I j plus 1th level del square u by del x square plus del square u by del x square at I j minus 1th level. So, then we can just have this relationship here, where I is varying from 1 to n minus 1 and j is varying from like your time scale, since it is just varying, we can just consider like 1 to n minus 1 there. So, especially if you will just see here, this equation just gives you a linear representation of u. Therefore, the formula for the error can be written in the same manner as we have defined for this explicit scheme. And this relationship can be written as since so u is a true solution and u star is the approximated solution. So, that is why if you will just take E as u minus u star at the particular points, then especially you can just write this one E at I minus 1 j plus 1 point as p minus 1 and q plus 1 point, which is defined at I minus 1 j plus 1 point there itself. So, that is why it can be represented as minus r square E of p minus 1 q plus 1 plus 2 into 1 plus r square E of p q plus 1 minus r square E of p plus 1 q plus 1. This equals to r square E of p minus 1 q minus 1 minus 2 into 1 plus r square E of p q minus 1 plus r square E of p plus 1 q minus 1 plus 4 E p q. Since I j especially it is just replaced by the point p q there itself. And if u is the true solution and u star is the approximated solution in each of these points, then we can just consider E as the error term at that points, which is nothing but u minus u star. So, if you will just put here E of p q is equal to e to the power alpha q del t and e to the power I beta p delta x here, then we will have this equation in the form like minus r square e to the power alpha into q plus 1 del t e to the power I beta p minus 1 delta x plus 1 minus 1 plus r square e to the power alpha into q plus 1 del t e to the power I beta p delta x minus r square e to the power alpha q plus 1 del t e to the power I beta p plus 1 del x. This equals to r square e to the power alpha q minus 1 del t e to the power I beta p minus 1 delta x minus 2 into 1 plus r square e to the power alpha into q minus 1 del t e to the power I beta p delta x plus r square e to the power alpha q minus 1 del t e to the power I beta p plus 1 delta x plus 4 e to the power alpha q del t e to the power I beta p delta x. If you will just take common e to the power alpha q del t e to the power I beta p delta x from each of these terms here, then we can just get this equation as in the form of minus r square e to the power alpha del t, since alpha q del t it has been taken common. So, that is why we will have here alpha del t only, and if you will just see the second term here, since I beta p delta x it has taken common. So, we will have these terms like in this form here. So, e to the power minus I beta delta x plus 2 into 1 plus r square. So, similarly, if you will just see here e to the power alpha del t it is just remaining over there, and e to the power minus I beta delta x minus 2 into 1 plus r square e to the power, so minus r square e to the power alpha del t e to the power I beta delta x, if you will just see from this term here, and all other terms it will just followed in the same manner to get the compact form as we have just considered in the earlier example. Or if you will just take this one as minus r square e to the power alpha del t, if you will just take common. So, this will be e to the power minus I beta delta x plus e to the power I beta delta x and plus 2 into 1 plus r square e to the power alpha del t, this is there. So, this term it has just taken, since minus r square e to the power alpha del t is taken common. So, that is why this term is added it up there. So, then the second side if you will just see here, or the right hand side, so it can be written as r square e to the power minus alpha del t. So, first term e to the power minus I beta delta x. So, it will be I beta delta x here. So, minus 2 into 1 plus r square e to the power minus alpha del t plus 4. So, or if you will just calculate this one in a combined form here, since e to the power minus I beta delta x plus e to the power I beta delta x, if you will just consider, that will nothing but it can just give you 2 cos beta delta x here. So, similarly we can write 2 cos beta delta x here also, and remaining terms are as there itself. And if you will just go for the further computation, so 2 is common in each of these terms if you will just see here. So, that is why 2 can be taken out from both these sides and it can be cancelled. And if you just write this equation in the final form, so this is just taking as 1 plus r square minus r square cos beta delta x e to the power alpha del t e to the power minus alpha del t r square cos beta delta x minus 1 minus r square plus 2. If you will just put here e to the power alpha del t equals to zeta here, we can just write this equation as 1 plus r square minus r square cos beta delta x into zeta. This equals to zeta inverse, since e to the power minus alpha del t it is there. So, r square cos beta delta x minus 1 minus r square plus 2 here. And if you will just multiply zeta at both the sides, so we can just obtain this equation in a transport form as 1 plus 2 r square sin square beta delta x by 2 zeta square plus 1 plus 2 r square sin square beta delta x by 2 into zeta minus 2 equals to 0 here. So, this is nothing but r square if you will just take common here. So, 1 minus cos beta delta x, that is why it is just taken as a 2 sin square beta delta x by 2 into r square. And here also same thing we have just done, since we are just considering r square here. So, if you will just consider this one minus r square common here, or r square if you will just take common here. So, this can be written as a minus 2 r square sin square beta delta x by 2 from these two terms here. So, this represents a quadratic equation in a zeta. So, if suppose two roots are there, zeta 1 and zeta 2, then we can just write the sum of roots as a minus b by a. So, that is why it can be written as like minus of 1 plus 2 r square sin square beta delta x by 2 divided by 1 plus 2 r square sin square beta delta x by 2. This is nothing but minus 1 here. And zeta 1 and zeta 2, this is nothing but c by a. So, c is nothing but here minus 2 by 1 plus 2 r square sin square beta delta x by 2, that is nothing but a here. So, for stability we have to consider zeta 1 absolute value it should be less or equal to 1, and zeta 2 absolute value it should be less or equal to 1. So, if you just consider this condition there, so we can just write absolute value of zeta 1 plus zeta 2, this equals to 1. Since absolute value you are just considering, so that is why minus 1 can be 1 there, implying that absolute value of zeta 1 plus zeta 2 it should be less or equal to 1 here. And if you will just go for like absolute value of zeta 1 it should be less or equal to 1, and absolute value of zeta 2 it should be less or equal to 1. If you will just put this condition in the second equation here, that is like zeta 1 plus zeta 2, that has a minus 1 there itself. So, we will have this equation, that is as two conditions it should be satisfied, absolute value of zeta 1 plus zeta 2 this equals to 1, and zeta 1 zeta 2 it should also be like minus 2 by 1 plus 2 r square sin square beta delta x by 2. So, that is why we will have like a absolute value of zeta 1 it should be less or equal to 1, and absolute value of zeta 2 it should be less or equal to 1. Hence, the scheme is unconditionally stable, and especially we can just say that implicit scheme is unconditionally stable for hyperbolic equations. Thank you for listening this lecture.